In this video, we will be solving trig identities. So how to solve? The first thing you're going to do is you're going to try to isolate the trig function, and then you will use either the unit circle or the calculator if required in order to be able to actually find the angle that we are looking for. So for example, I need to isolate sine. So in order to do that, I'm going to subtract 1. So sine of theta equals -1. So now you got to think of where on the unit circle is sine. Remember, sine is your y value. Where on the unit circle is your y value equal to a -1? And that happens at 3 pi over 2. Now, if it doesn't tell you specifically whether it should be radians or degrees, you can do either one or the other, or you can go ahead and do both. So at 270 degrees or at 3 pi over 2. Next example, again, we are going to isolate the trig function. So we're first going to add 1. And then we're going to divide by 2. And so now on the unit circle, where is your y value, because sine is y, where is your y value equal to 1/2? And that happens at pi over 6, but that also happens at 5 pi over 6. It's going to happen many times. It's going to happen in more than one place, so make sure you do put all of those on there. Again, if this was the degree, then you would just convert to degrees, which happens at 30 degrees, and it happens at 150. So what I need you to do in order to get the cosines together is I'm going to go ahead and subtract cosine from both sides, and I'll get -2 cosine. And now I need to divide by -2 to equal cosine. And so now, where on the unit circle is cosine, which is your x value? Don't forget that's your x value. Where is your x value equal to a -√3 over 2? And that happens at 5 pi over 6. And that also happens at 7 pi over 6. And then again, if you want to put in the degree mode, then it would happen at 150 degrees, and it would happen at 210 degrees. To solve for sine, I need to first add 3. And then I need to divide by 4. Now this is squared, which means we need to take the square root. And whenever you take the square root, you will get a plus or minus. So we are going to be looking for two different places on the unit circle. When is sine, again, sine is your y value, when is sine equal to a positive square root of 3 over 2 and also to a negative square root of 3 over 2? And so let's talk about positive first. Sine is positive at square root of 3 over 2 at pi over 3 and at 2 pi over 3. Now, sine is negative square root of 3 over 2 at 4 pi over 3 and at 5 pi over 3. So you actually will get 4 answers in this case. Next, I cannot divide both sides by cosine in order to cancel them. You cannot do that in this case. And the reason why is because if cosine was 0, you would be dividing by a 0, which is not possible. So here's what you're going to do in situations like this. You're going to subtract cosine from both sides. You'll get 2 cosine theta times sine theta minus cosine theta equal to 0. And then from here, if you notice, you have a cosine in both terms, so you can factor out a cosine. And when you do that, you'll get 2 sine theta minus 1 equals 0. And because it's equal to 0, you can actually set them up both equal to 0. Cosine of theta equals 0, and 2 sine theta minus 1 equals 0. So first over here, where is cosine, your x value? Where's your x value 0? That happens at pi over 2, and that happens at 3 pi over 2. So that is your first set of answers. Now you got to do this set. To solve for sine, you are going to have to add 1 and divide by 2. And so where is sine 1/2? Sine is 1/2 at pi over 6 and at 5 pi over 6. And so in this case, you actually have 4 different answers again. To solve for tangent, I'm first going to add 1. And now to get rid of the square, I'm going to take the square root. And the square root of 1 is plus or minus 1. So we're looking for when tangent is a positive 1 or a negative 1. Now, if you think of tangent as a quotient reciprocal of sine over cosine, in order for sine divided by cosine to equal 1, that means they have to equal the same number. And that happens when they both are square root of 2 over 2. And the only time that sine and cosine are the same is at the pi over 4s. And because tangent, we're looking for 1 and negative 1, it is going to be pi over 4, 3 pi over 4, because that would give me a negative 1, because cosine's negative, 5 pi over 4, and 7 pi over 4. This looks a little weird because you have cosine that is in multiple places, but let's go over here for a second and notice something like this from Algebra 2 and Algebra 1. This factors into x minus 2 times x plus 1, which means you can solve by setting them both equal to 0, correct? So therefore, you know that x equal 2 and x equal negative 1. We are going to do the same thing. This actually factors in the exact same way. So instead of it just being x minus 2 and x plus 1, it will be cosine minus 2 and cosine plus 1. So we're going to set both of these parentheses equal to 0 and solve. So cosine of theta is going to equal 2, and then cosine of theta is going to equal negative 1. Now, if you notice, this does not happen anywhere on the unit circle. And if you were to put this in the calculator, like if you were to find the inverse of cosine to find the angle, it would give you an error because cosine can never equal a number greater than 1. So the only way you're going to get an answer is on this side. So cosine, when does cosine equal negative 1? And that is at pi. We're going to do the exact same thing. This actually can factor into 2 sine minus 1 plus 1. And now we can set them both equal to 0. And so on this side, sine of theta is going to equal negative 1/2. And on this side, sine of theta is going to equal 1. So on the unit circle, sine is a negative 1/2 at 7 pi over 6 and 11 pi over 6. On this side, sine is equal to 1 at pi over 2. In this case, we need to get the signs together, so I'm going to subtract 2 sine from both sides. And then I'm going to add 2. And then I'm going to divide by 2. And so we're on the unit circle, a sine equal to 1. Again, it is at pi over 2. In this case, I'm going to first add 1 and divide by 2. I'll get cosine squared equals 1/2. And so now I've got to take the square root of both sides. When I do that, I'll get cosine of theta equals plus or minus the square root of 2 over 2. Now, why is that? Square root of 1/2 is 1 over the square root of 2. Now, you have to rationalize the denominator. And that is how you get the square root of 2 over 2. Because 1 over the square root of 2 is not on the unit circle. Well, it is. You just don't notice it because it doesn't look like that. It actually looks like square root of 2 over 2. So where is your x value, the square root of 2 over 2, and the negative of it? And that happens at the pi over 4. So you have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, sometimes you're going to have different trig functions and you're going to have to manipulate them to get the same trig function together. So for example, I need cosine squared to look like sine, or I need sine to look like cosine. And I can't really do anything with sine, but there are some identities that deal with cosine squared. We know that cosine squared plus sine squared equals 1, which means we know that cosine squared is 1 minus sine squared, because if you subtract sine, I am going to take that and substitute it in for cosine. So instead of cosine squared, I'm going to put in 1 minus sine squared. Now, I'm going to go ahead and from here solve. I have negative sine squared plus sine squared, plus sine equals 0, because when I subtract 1, I get 0. Now I can factor. I can pull out a sine, and I'll be left with negative sine plus 1. And now I can set them equal to 0. So sine of theta equals 0, and negative sine of theta plus 1 equals 0. Sine is 0 at 0 and pi. Here, I subtract 1, but I got to divide by a negative, so this turns positive. And sine is 1 at pi over 2. Now, there is something called multiple angles. So you're going to actually solve the equation the exact same way as others, but something's going to happen at the very end. So right now, do not mess with the 2. That is trapped inside of the sine function, so do not touch the 2. Do not divide both sides by 2. First thing you're going to do is actually go ahead and determine when is sine equal to square root of 3 over 2. So when is sine equal to the square root of 3 over 2? So in the unit circle, that happens at pi over 3, and that happens at 2 pi over 3. Now, here's what you do. You now take those answers and you actually set that equal to 2 theta instead of just theta, because normally that would be your answer, but that is 2 times the angle to get you there, which means now you would divide by 2 and you would get your answers, which happens at pi over 6 and pi over 3, because that's 2 pi over 6, which is pi over 3. So you solve it the same way in the unit circle, but at the very end, you're going to divide by whatever is attached to that angle. So in this case, to solve, I first need to go ahead and get this cosine of 1/3 theta by itself. So I'm going to add 1 and divide by 2. So cosine of 1/3 theta equals 1/2. So first, on the unit circle, where is cosine equal to 1/2? And that happens at pi over 3, and that happens at 5 pi over 3. But that's not your answer, because that is set equal to 1/3 theta. So to solve, you're going to multiply by 3. So therefore, you should get pi, and you should get 5 pi for your answers, because 3 divided by 3 is just 1 pi and 5 pi. So in this case, same thing's going to apply. This is going to give me sine squared of 4 theta is equal to 1/2. I got to get rid of this square by taking the square root. So sine of 4 theta is going to give me plus or minus the square root of 2 over 2. So first we need to determine when is sine equal to the square root of 2 over 2 and negative. And that happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. But that should be set equal to 4 pi. So I now need to divide everything by 4, and I'll get pi over 16, 3 pi over 16, 5 pi over 16, and 7 pi over 16 as your answer. So to recap, pause the video, attempt to do these problems, and then resume to check your answers. So sine is in the denominator, so we cannot set it equal to 0. And so because if you set equal to 0, you would get 0 in the denominator, which is undefined, or no solution, not possible. And so you are only going to take the numerator and set it equal to 0. So when you do that, you will get a negative 1/2. But when you take the square root, here's the problem. When you take the square root of both sides, you cannot have the square root of a negative. And so therefore, you actually get no solution. And I can't spell no solution. Over here, you cannot divide both sides by cosine, because if cosine equaled 0, you would get, again, undefined. So what you have to do is just subtract cosine and set equal to 0, and then factor out a cosine. And so you will have two things set up: cosine equals 0, and then cosine squared minus 1 equals 0. So cosine equals 0 at pi over 2 and 3 pi over 2. And then here you would have cosine squared equals 1, and then you got to take the square root, and you'll get a still plus or minus 1. And so therefore theta will equal 0 and at pi for 1 and positive 1.